So thank you very much. My name is Jared Ortiz. I am the director of the St. Benedict Institute and professor here at Hope College. So again, thank you all for coming out to tonight's lecture. Tonight's lecture is part of our fall series on creation, evolution, and our place in the cosmos. And this series is made possible by Collegium Institute's Lemaitre grant, which is part of their Magi project for faith and science. So in addition to Collegium, I'd like to thank our other sponsors for tonight, the Dean of Natural and Applied Sciences, the Physics Department, the Religion Department, and the Cultural Affairs Committee. The goal of this lecture series is to show that faith has nothing to fear from science, but is actually in harmony with it, and can even encourage our Christian convictions. And we invited two scholars. The first was Sister Damian Marie Savino, and tonight the physicist Stephen Barr. So we invited two scholars, both Christians, both scientists, who demonstrate the harmony of faith and reason by their lives and by their scholarship. Stephen Barr is the president and founder of the Society of Catholic Scientists. He's professor emeritus of the Physics Department and the Department of Physics and Astronomy at the University of Delaware, and the former director of the Barr Research Institute. He's the author of Modern Physics and Ancient Faith. Tonight, he will present The Big Bang, the Beginning, and Creation. Please help me welcome Dr. Stephen Barr.
Thank you for coming out to hear me. Can you hear me okay? Okay, good. I think I'm going to take this off. So I'm going to talk about, as you heard, the Big Bang and creation. Now, many religious people think that the universe, see the fact, if it is a fact, that the universe had a beginning as proving that the universe was created. And some people even refer to the Big Bang as the moment of creation. For their part, many atheists think that if the universe had no beginning, for example, was past infinite, it would prove there was no creator. Now, I think both are making the same mistake in simply identifying the temporal beginning of the universe with creation. I'm going to argue that these are quite distinct notions. At first glance, it seems that the Bible itself identifies beginning and creation because it says, "In the beginning, God created the heavens and the earth." This verse certainly speaks of both a beginning and creation, but does not actually say that they mean the same thing. Creation refers to the fact that the universe depends for its existence upon God, who is the source of its being. Whereas beginning refers to the universe having a temporal starting point rather than having a history that stretches back infinitely into the past or that goes around in a loop. The Catechism of the Catholic Church, in explaining Genesis 1:1, treats beginning and creation as distinct components of its meaning. In section 290, it says, "Three things are affirmed in these first words of Scripture. The eternal God gave a beginning to all things that exist outside himself. He alone is creator, and the totality of what exists, expressed by the formula of the heavens and the earth, depends on the one who gives it being." So although being created and having a temporal beginning or starting point are distinct ideas, many theologians, philosophers, and ordinary people have seen them as connected in a necessary way. For example, the great 13th century Franciscan theologian St. Bonaventure, a contemporary of St. Thomas Aquinas, believed that each implies the other. The universe being created implies it has a beginning, a temporal beginning, and the universe having a temporal beginning implies that it is created. On the other hand, his contemporary, St. Thomas Aquinas, disagreed, seeing the two notions as independent of each other. St. Thomas believed that God could have created a universe that was past infinite if he had chosen to do so, but that as a matter of fact, God chose to create a universe that had a temporal beginning, that is, a finite age. In St. Thomas's view, we only know the universe has a temporal beginning because God chose to reveal that to us in Scripture, Whereas the fact that the universe is created, he felt, could be shown even without divine revelation by the natural light of human reason and proved philosophically. Now, you might ask, how can God be the cause of being of something if that thing has no temporal beginning or starting and has always existed? So let me give you an analogy. Imagine, look at this screen. This screen is illuminated. It's bright. Why? Because it's being illuminated by a light. That light is the cause of its brightness. That doesn't tell us, so its brightness has a cause. That doesn't tell us whether it's been illuminated for an infinite time or for finite time. It could be that this screen has been bright for infinite time, in which case it's always had that means the light has been illuminating it for infinite time. So the illumination would have, in that case, no beginning, but it always have a cause, the light. In the same way, you could imagine a universe that has existed for infinite time. It has being, because that being is conferred on it by a cause of being, God, analogous to the light of the screen being caused by the light in the back of the room. So God is conferring being on it, but could have been doing that for infinite time. So the two are distinct questions, the age of the universe and whether it has a source of being. Now, another way to get this distinction, and I'll explain why it's an important distinction in a minute, but another way to see it is to say that there's a difference between something having a beginning and asking what the beginning of something is and what is its origin. So take, for example, a piece of music like a symphony. A symphony has an internal sequence measured by notes or beats. There are first notes, the beginning of the symphony are the first notes in that internal sequence. But the cause of the symphony, its origin, is the mind of the composer. A novel has an internal, it's a sequence of words. The beginning of the novel is simply a set of words at the beginning of that sequence. But the cause of the novel, the origin of the novel, is the mind of the novelist. In the same way, the beginning of the universe is just a set of events that happened a long time ago, maybe at the time of the Big Bang. That's the beginning. But the cause of the origin of the universe is the mind of God, the mind of its creator. Now, so if someone were to ask you, why does this book exist? Is there a novel, A Tale of Two Cities? Well, it begins with the words, it was the best of times, it was the worst of times. So if you had this novel and someone said, why does this novel exist? Why is there this novel? You would be foolish to open it and say, see these words at the beginning? It was the best of times, it was the worst of times. That's why there's a novel. No, it's a novel because Dickens wrote the novel, because it has an author. It was conceived of in the mind of a novelist. In the same way, if somebody asks you, why is there a universe? Why is there a universe? Why does it exist? It would be foolish to point to some set of events within the history of the universe as the cause of that. That's just a set of events in the history of the universe. The cause is the creator. That's what creating is all about. Now, so the creation, God's creative act, so God is, if you're asking about creation, it's not something that just happened a long time ago. Creation happens right now. Why? Take something like this phone. It exists. It's real. It has being. It's not a merely hypothetical phone or a possible phone. It's a real existing phone. It has existence because God is conferring existence. God is the source of its being. And so God is creating this phone right now. God creates everything that has being whenever it existed in the history of the universe or wherever it exists in the universe. If it's real, if it has being, then God is conferring being upon it. So God equally is creating now, creates the things that are happening now, the things that happened in the past, the things that happen in the future. Just as the novelist creates every word of the novel, not just the ones at the beginning. The novelist equally creates every word of the novel. This composer equally is the creator of, or the author of, every note of the symphony, not just the ones at the beginning. Now, of course, so God's creative act, the traditional Christian view, is that God's creative act is not something that happened just a long time ago. It is an act of the divine mind, and God being outside of space and time, beyond space and time. It's the act of God in creating the world is not an event that happens in space and time. Its effects happen in space and time, but God's act does not. His creative act. It is a single, eternal, timeless act by which God wills the existence of the whole universe and all of its parts from beginning to end. Okay? Now, admittedly, Genesis does speak of God creating in the beginning. And theological tradition also distinguishes God's act of creating in the beginning and his act of conserving the world in being later. But actually, theological tradition also says that that distinction is merely on our part. That is an accommodation to our time-bound way of looking at things. From the point of view of God, they're the same act. The creating and the conserving are one and the same act of God. We see things in time. We are crawling along through time, and so that's the way we look at things. But the distinction between creation and conserving and being, according to traditional theology, is merely a notional distinction. Now, okay, so that's the traditional Christian understanding of divine creation. And you see from it that physics has nothing to say about it, can have nothing to say about it. Physics studies the universe and its parts and what goes on in it. It studies how one physical thing causes another physical thing. But God creating the universe is not a physical process. God is not a physical thing, and his creation is not one physical thing acting upon another physically. So physics has nothing to say about creation. Physics can tell us about the beginning, possibly. It can tell us what things happened, a lot about what happened early in the history of the universe, maybe eventually tell us what happened at the very beginning of the universe as far as the events going on in the universe. But it doesn't tell us about creation. It tells us about beginning, but not creation. Now, some religious people have the notion that the events at the beginning of the universe must have been miraculous in the sense that they cannot be described by science or that they violated the laws of physics. There's a very common notion that, well, surely what happened at the beginning was a miracle, or it violated the laws of nature. Now, part of the reason some people think that is that they hear about something called the initial singularity of the universe. I don't know if you've heard this term, but it's an important concept in physics, and so I'm going to tell you what it's all about. If you're talking about how the universe expands, the history of the universe as a whole, that is described using Einstein's theory of gravity, the expansion of the universe. Now, if you try to describe the evolution of the universe, the expansion of the universe, using Einstein's theory of gravity, but you leave out quantum mechanics, that works very well for most of the history of the universe. But if you extrapolate back to the very beginning and you're describing things just using Einstein's theory of gravity, but leaving out quantum mechanics, what you find is that you come to a point, let's call it t equals 0, where certain physical quantities would be infinite. For example, the density of energy in the universe, the farther you go back in time, the more compressed the universe was, the denser it was. And if you go back in time, the density of energy or the density of matter in the universe goes as 1 over t squared. So when you go to t equals 0, it would be infinite, which means you can't actually use the equations there. You're not allowed to divide by 0. So 1 over t squared means you can't use the equations when t equals 0. So the laws of physics would break down at that point. And that would be called the initial singularity. However, we know that that's the wrong thing to do. You should not leave quantum mechanics out of your calculations when you're talking about things very early in the history of the universe. Near the beginning, things were so dense that you have to use quantum mechanics too. And it seems nobody knows how to do the calculations when you include both Einstein's theory of gravity and quantum mechanics. Nobody knows how to do the calculations. But it is generally thought that that there are reasons why physicists believe that if you did the calculation correctly, if we knew how to do it correctly, things would not be infinite there. You would not have to divide by zero, that the laws of physics would apply perfectly well at the beginning moments of the universe as later. So the initial singularity is a bit of a red herring. Now, should we be bothered if it turns out, as I think it's likely to turn out, that the laws of physics work perfectly well at the beginning of the universe, and that what happened back then at the beginning were processes that are perfectly well explained, can be explained using the laws of physics? No, I don't think there's any reason for a Christian to be upset at that at all. So think of a novel again. The laws of physics, you might make the analogy that the laws of physics are to the universe the way the laws of grammar are to the novel. And there's no reason to think that the laws of grammar should not apply to the first sentences of the novel as to all the later sentences. And if they did, if they found out that the first sentences of the novel obeyed the laws of grammar of whatever language the novel is written in, that doesn't mean there's no author. And in the same way, just because the same grammar of the universe, the laws of physics, applies at the beginning as later, doesn't mean the universe has no author. The two questions are unrelated. And yet, some atheists have actually made this very argument. They say that if physics could explain or describe adequately what happened in the first stages of the universe's history, that would prove that there was no creator. For example, the late Stephen Hawking, towards the end of his life, argued in this way. He suggested that the full equations of physics, and this part I think is perfectly reasonable, that the full equations of physics, if we knew what they were, may both require the universe to have a beginning and also adequately describe the physical events that occurred at that beginning. But then he went on from that to say that if this were the case, it would mean that the creator was not needed. If physics can describe what happened at the beginning, then you don't need a creator anymore. Now, the answer to this is actually quite simple, and strangely enough was given by a physicist every bit as great as Hawking. Do you know who that was? It was Hawking. Hawking. Years earlier, so in 1988, he wrote a very popular best-selling book called A Brief History of Time. And in it, he said, a theory of physics is just a set of rules and equations, just a set of mathematical rules and equations. And he said, what is it that breathes fire into those equations and makes a universe for them to describe? The usual approach of science of constructing a mathematical model cannot answer the question of why there should be a universe for the model to describe. Okay? Now, he's actually putting his finger back then exactly on the question of creation. So let me explain what he's saying with an analogy. You may possess a book that contains the rules of a game. It could be football or baseball or chess, okay? Let's say baseball. The rules of baseball would describe how baseball games begin. It would describe how they end. It would describe the kinds of events that go on in baseball that can happen, under what circumstances they can happen, in what order they happen, how some events can cause some other event. You touch the runner, he's out, and all this kind of stuff. It can describe all of that. But one thing the rules of baseball cannot tell you. They cannot tell you whether there's an actual, real baseball game being played, or whether one has ever been played or ever will be played. The rules could be describing merely possible or fictitious or hypothetical baseball games. They don't have they not only don't tell you whether there's an actual real baseball game, they don't have the power to make there be a real baseball game. And as Hawking is saying here, the laws of physics are like the rules of this big game we call the universe, very serious game, but they're like the rules of the universe. And those rules describe the kinds of things that go on, the circumstances, the sequence, and so on, how the universe would begin, how it would end. They can't make there be a real universe described by those rules. They haven't the power to do that. And that's what he says. the usual approach of constructing a mathematical model, cannot answer the question of why there should be an existing universe that is described by those. And so actually he answered himself decades before he made this argument. So if somebody asks, why is there a world? And the famous philosopher Leibniz asked, why is there something rather than nothing? If you say, why is there a world? There are two answers that are perfectly self-consistent. One is that there's a cause of being. It has being because of a cause of being, and that leads you towards theism. Or you could say there's no reason. It's a question without an answer. It just is. The universe just exists. There's not a reason why it exists. It just does. And that's the atheist answer. And they're both self-consistent. And it's up to you to decide which one is more intellectually satisfying. But those are the only two options on offer. No one has ever, until Hawking, I don't think anyone else ever proposed a third answer, and Hawking's answer, that it's the laws of physics, simply makes no sense, as he himself, for reasons that he himself explained many years earlier. You can be an atheist, you can be a theist, but to say that the laws of physics explain why there's a universe is simply, it doesn't make any sense. Okay, now that's what I've up to this point been talking about creation and how that's not the same thing as beginning. So, by the way, that means that physics has nothing to tell us about creation. It may tell us, I said, very interesting things about the beginning of the universe, but it's not going to tell us anything about whether the universe is created or not. Now, so now let's talk about the beginning of the universe. We know the universe is created, but do we actually know that it had a beginning? I mean, we as Christians believe that it's created, but what do we know about whether it had a beginning? And if we do know, how do we know? What do we know from divine revelation? What do we know from philosophical reasoning? And what can empirical science tell us about it? So let's start with revelation. The church has traditionally understood Genesis 1:1 as teaching that the world did have a temporal beginning. So, for example, both the Fourth Lateran Council in 1215, do I have it up here? Well, I said, and the First Vatican Council in 1870 taught that God created the universe ab initio temporis, from the beginning of time. Okay, so we believe as Christians that there was a beginning. Now, let's leave revelation aside and ask about philosophy. If we didn't have divine revelation, what would we be able to determine about this? Now, if we turn to the pagan philosophers of ancient Greece, including Aristotle, and probably also Plato, we find that they believed neither in creation, as we understand it, nor in a temporal beginning of the universe. Indeed, St. Augustine relates in his Confessions around the year 400 AD, that some pagans of his day mocked the idea that the universe was created, that there was a creator of the universe, and that the universe came into being a finite time ago. And they would mock the Jews and Christians for believing this, and they said, what was your God doing for all that infinite time before he got around to making the world? He was sitting around for an infinite time and then only recently decided to make the world or call it into being. Now, to this question, St. Augustine gave a very profound answer in the 11th book of his Confessions. He pointed out that time is a measure of change, and therefore you only can really talk about time when there are changeable things, when there are things that are changing. And that means created things. So time is a feature of the created world, and indeed time itself is something created. If time is passing, it means there are changeable things in existence, which means creation has, in a sense, already occurred. So it's nonsensical, he said, to speak of a time before creation. It's a contradiction in terms. So St. Augustine answered the pagan taunt in these words. He said, after discussing a long discussion, he said, but if there was no time before heaven, there can't have been time before heaven and earth, meaning the universe was created. There was nothing to change. So there can't have been such a thing as time. But if there was no time before heaven and earth, why do they ask what you, O Lord, did then? There was no then where there was no time. In other words, the beginning of he was saying that the beginning, whenever the world began, that was also the beginning of time itself. Now, others had spoken of, so actually, modern physics has come to a similar conclusion about 15 centuries later, but by a different route. So St. Augustine started with the insight that time is something created, whereas modern physics starts with the insight that time, space-time, is something physical, ever since Einstein's theory of gravity, his theory of general relativity. Now, in Einstein's theory, space-time is something physical, just as physical as matter or forces. Now, if time or space-time is something physical, then the beginning of the physical universe must also have been the beginning of space-time. So if the universe had a beginning, modern physics sees that if the universe had a beginning, then it doesn't make sense to talk of a time before that or of there being space before that. Those are parts of the universe, aspects of the universe. So the beginning of the universe is the beginning of space and time. So if the universe, for example, began 14 billion years ago, as seems most likely, then it would be meaningless to even talk about 20 billion years ago. If the universe began 14 billion years ago, there's no such thing as 20 billion years ago. It's not that there was nothing going on then, it's there's no such thing as then. And in the same way, it doesn't make any sense to talk about points on the Earth's surface north of the North Pole. That's as far north as you can get. There's no more north than the North Pole. There's no earlier than the beginning of the universe. So St. Augustine's insights, okay, so that is a digression. That's going back to theology a bit, but it is also leading us to how physics sees the beginning. It's the beginning of the universe is the beginning of not only matter, but of space and time itself. That's how we look at things now. Now, but let's return to philosophy. The philosophers of antiquity, who were pagans, such as Aristotle, thought, as I said, generally thought that time had no beginning, that the world had always existed. But some later philosophers argued that one can prove by philosophical reasoning, just by thinking, one can prove that time must have had a beginning. There are philosophers alive today who also argue this way. It's claimed, for example, by the proponents of the so-called Kalam argument for the existence of God. This argument is supposed to have originated in the 11th century with certain Muslim philosophers, in particular one named Al-Ghazali. And the most well-known modern proponent of this Kalam argument is the Protestant philosopher and apologist William Lane Craig, though it's also recently become fashionable among some Catholic philosophers. The Kalam argument purports to prove the existence of God in two steps. The first step is that they prove philosophically, or they claim to prove philosophically, that the universe must have had a beginning in time. And the second step is to argue that any entity which has a beginning, it must also have a cause outside of itself. So if the universe began, it has to have a cause of its beginning that's outside of itself, but if it's outside of the universe, then what else can it be but God? Now, several medieval scholastic philosophers also believed that you could prove philosophically that the universe had a beginning. A notable example is St. Bonaventure. He was a contemporary of St. Thomas Aquinas. Oh, I already said that. Now, St. Bonaventure had a set of arguments by which he attempted to prove that the universe must have had a beginning. And the way he attempted to prove it is by saying, let's suppose that the universe were infinitely old, and we'll show that that leads to absurdities or contradictions. Okay, so he said, let's suppose, and that's what's called a proof by contradiction. So he said, let's suppose the world is infinitely old, and let's see where that takes us. So he thought of the history of the universe unfolding in days, which is a convenient way to think of it. So if the universe is infinitely old, that means there's an infinite sequence of days going all the way back. So he said, there's a day, that's today, that's the present day. And if the universe, he said, is infinitely old, there must have been some days that were infinitely far in the past. So let's take one of those days, and that's that one, that's infinitely far in the past. And let's think about that day. Well, the day after the one that's infinitely far in the past must also be infinitely far in the past, because infinity minus one is still infinity. And the day after that, still infinitely far in the past, as is the day after that and the day after that. And by mathematical induction, every subsequent day is still infinitely far in the past, so you can't get from there to here by the passage of time. The passage of days can never get you from that infinitely remote day to present, which means that day is not actually in our past, because the passage of time cannot bring you from that day to this one. So it's not actually in our past, which means you've just gotten a contradiction because you said that it was in our past. Now, the fallacy here is immediately recognized by anyone who's taken some mathematics, and anyone of 21st century or 20th century who knows some math will say that the fallacy was the first step. Saying that the world is infinitely old and has maybe an infinite sequence of days in the past does not mean that any particular day is infinitely far in the past. And you can see that by considering the natural numbers, 1, 2, 3, 4, 5, 6, and so on. There's an infinite set of such numbers. They go on forever. But even though there's an infinite set of natural numbers, every single one of those numbers is finite. So even if the past were infinite, every single day is a finite time in the past. Every particular day. So his argument is fallacious, and his other arguments were equally fallacious. So there are, as I said, philosophers, very smart people who think that they have proven that the universe must have a beginning, but I don't think they have generally convinced philosophers generally or mathematicians that this is the case. Anyway, St. Thomas did not see these arguments as compelling. He said, he was a contemporary of St. Bonaventure, he said he was aware of no compelling argument, philosophical argument, that time had to have a beginning. We only know that from Revelation, he said. Okay, so I think I would say, it's a question, it's disputed, but I would agree with St. Thomas that philosophy doesn't lead to any conclusion about the age of the universe, whether it's finite or infinite. Now, what does empirical science tell us? Well, empirical science, up to recently, up until the 20th century, was not really in a position to say anything about whether the universe was infinitely old or not. However, a lot of things seem to point to it being infinitely old. For example, in the 19th century, it was discovered that the energy can neither be created nor destroyed, conservation of energy. The amount of energy does not increase or decrease. Energy, as we learn in school, cannot be created or destroyed, but only change from one form to another. Similarly, chemists discovered in the 19th century that the number of atoms in chemical reactions doesn't change. They can combine in different ways, but the number of atoms doesn't change. So, in chemical reactions. So it seemed to people then that matter was indestructible, and it had to always have been here. You couldn't make new matter or new energy. You can't get rid of matter or energy. So it must have always existed and would always exist. And that's why this Nobel Prize winner in chemistry, Svante Arrhenius, said, the opinion that something can come from nothing is a variance of the present-day state of science, according to which matter is immutable. And a Nobel Prize winner in physics, Walter Nernst, said, to deny the infinite duration of time, and I think he was thinking about the past, would be to betray the very foundations of science. So scientists, and actually I've read that there was a survey of American astronomers that showed that even in the 1950s, the great majority of American astronomers thought that the universe was infinitely old. So science seemed to be pointing to an infinitely old universe, at least to a lot of people. However, in the 20th century, things changed. It was very hard in the 19th century to imagine how the universe could have had a beginning. It didn't fit with our views of with our views about physics. But things changed a lot in the 20th century. And they changed because of Einstein's theory of gravity, which is called general relativity, which he published in 1915. Now, it was quickly realized that by two people, independently of each other, that the equations of Einstein's theory of gravity could describe a universe that's expanding. One of these people was a Russian mathematician named Alexander Friedmann, and the other was a Belgian theoretical physicist named Georges Lemaitre, that gentleman, who also happened to be a Catholic priest. So Friedmann did work on this, and things are named after him in the field of cosmology. However, he died in the 1920s, and therefore his ideas were not really picked up, except independently, Georges Lemaitre had come up with similar ideas, and actually he carried them much further than Friedmann had. Lemaitre pointed out that the universe could be expanding according to Einstein's theory of gravity. Lemaitre was aware of observations being made by American astronomers, in particular Edwin Hubble, after whom the Hubble Space Telescope was named. That Hubble was discovering that distant galaxies were flying away from us at great speed. And so Lemaitre realized that these galaxies flying away from us could be a sign that the universe is expanding. And so first of all, in 1927, he wrote a paper in French in a rather obscure Belgian scientific journal proposing that the universe is in fact expanding. And he also wrote down an equation that describes its expansion. And it was a prediction of his. The equation related how far a galaxy is from us to how fast it's going away from us. Now, 3 years later, Hubble, not knowing of Lemaitre's work, very few people knew of it, discovered that the universe, that these galaxies are flying apart, and in a way and he came up empirically with the same equation that Lemaitre had theoretically predicted from Einstein's theory. Hubble discovered this equation that found it described what the galaxies were doing, and that equation was named after him, the Hubble law of expansion. Now, at a certain point shortly after that, it was discovered that Lemaitre had actually predicted this 3 years earlier. Nevertheless, it still kept being called the Hubble law until 2018, when the International Astronomical Union, which is sort of the world organization of professional astronomers, voted overwhelmingly that this law should really be called the Hubble-Lemaitre law. So he's now getting his due. But he's recognized universally in the physics world, in the world of cosmology, that then in 1930, Lemaitre proposed further that not only was the universe expanding, but that it was expanding from some very dense state, which he called that there was originally, a finite time ago, a very dense state of matter, which then exploded and to lead to the expansion of the universe. And he called it the primeval atom. And we now call it the Big Bang. But he is regarded he is correctly regarded as the proposer of the Big Bang theory of cosmology. And it was not just some speculation. It was backed up with a lot of calculations based on Einstein's theory of gravity and so on. So he is the father, if you will, of the Big Bang theory. Now, that may seem to answer the question. For a while, the Big Bang theory was, people were not sure that it was right. It had some problems. But over time, the problems sort of worked themselves out, and people discovered in the 1960s it was cosmic radiation left over from the Big Bang was discovered by Arno Penzias and Robert W. Wilson. They detected radiation filling all of space that is now understood to be the radiation left over from the Big Bang. They got the Nobel Prize for that. And ever since then, evidence has been accumulating rapidly. There's now overwhelming evidence that there was a Big Bang about 14 billion years ago. Now, in the standard model of cosmology, that Big Bang is assumed to be the beginning of the universe, and in fact, the beginning of matter, space, and time. That doesn't, however, resolve the question definitively, because it is possible to extend the Big Bang model in various speculative ways. And over the last almost more than 80 years, actually more than 90 years, physicists and cosmologists have proposed a number of very speculative scenarios. They're scenarios, they're not theories that are testable, they're just scenarios, according to which the Big Bang was not the beginning of the universe, but rather just one event in a history that stretches back further. So it's possible that there was a pre-Big Bang history of the universe. And some of these scenarios are quite interesting, and one of them might turn out to be correct. However, even if one of these scenarios is correct, there are very strong arguments that even if the Big Bang was not the beginning and there was some pre-Big Bang history, that there was a beginning at some point earlier. So there are theoretical arguments that there probably had to be a beginning of the universe and of space and of time. So I can tell you a couple of these scenarios. So one scenario that Einstein himself played with back in 1930 is this idea of a bouncing universe. So the idea was the universe is expanding. It might expand, and then the expansion might reverse and turn into a collapse. And then, now if that happens, what generally assumed would result is what's called the Big Crunch. So you might have a Big Bang, the universe expands, reaches some maximum size, and then collapses back on itself due to its gravitational self-attraction into what would be called the Big Crunch, and that would be the end of time and the end of space and matter. But you might imagine, and there's no compelling reason to think this would happen, but you might imagine that instead of a big crunch, and that's the end, that it bounces. Bounces and starts another cycle of expansion, which then leads to a collapse and then another bounce. So you have an infinite, it's called the bouncing universe scenario. The trouble is, back in 1930, a famous cosmologist showed that these bounces would not all be alike. It wouldn't just be the same bounces happening over and over. That because the universe would be constantly heating up, and therefore each bounce would take longer than the preceding bounces. So if this is a bounce, then the next one would take a longer time. And if you to go back in time, the bounces were shorter and shorter. And in fact, in such a way that all the previous bounces would add up to a finite time because they're getting shorter and shorter and shorter. So the bouncing universe does not, even if there were bounces in the past, it seems that the universe had to have a beginning in that scenario. There's other scenarios I won't go into, one called eternal inflation, which is very popular now, but there are very strong arguments that in those scenarios too, the universe had to have a beginning. And the most basic reason why it probably had to have a beginning is something called the second law of thermodynamics. The second law of thermodynamics says that the universe, a certain measure of disorder, I should say, in the universe is always increasing. There's a certain measure of the disorderliness of matter, which is called entropy. And disorderliness is always increasing on the whole. You're always going from more order to more disorder. Okay? And that's why if you leave an ice cube on the kitchen table, the ice cube's very orderly structure of atoms, a nice orderly pattern, but it melts into a very disorderly puddle, okay, where the atoms are moving around in a random way. This going from order to disorder is why things grow old, why they decay, why they crumble, why things rust, why we die. Everything gets older and crumbles and decays and dies and so on. So you're always going from order to disorder. It's the reason why we will all eventually die, because of the second law of thermodynamics. The second law of thermodynamics is the reason that physicists believe that there cannot be what are called perpetual motion machines. You can't have a machine that just keeps chugging along forever. It will eventually wear out because of the second law. And if the universe were infinitely old, it would be kind of like a perpetual motion machine. It would have been a machine, as it were, that had been running for infinite time. And so that's the gist of it. That's why it's very hard to construct models of the universe that are infinitely old without running afoul of this fundamental law called the second law of thermodynamics. There's other reasons why it's hard to construct viable models of a past infinite universe. So again, this is not definitive. There still are models out there. People continue to construct models to show that the universe could be infinitely old. These models tend to be very complicated and sort of Rube Goldberg. I don't know if people still know who Rube Goldberg was. Very complicated, sort of artificial and not very plausible models. So I think there's very powerful reasons, and I think most physicists would agree that very powerful reasons to say that the universe probably had to have a beginning. So that's that. That's all I'm going to say. Religion tells us, at least traditionally, it's Genesis has been 1:1 has been interpreted to imply that the universe had a beginning. Philosophy probably doesn't answer the question. Physics probably can't definitively answer the question, but it gives us a lot of evidence pointing to a beginning. Okay, so I think that's all I'm going to say about the beginning and creation. But I might say something about, I should say, interject one thing here. If beginning and creation are separate questions, why does it theologically matter whether the universe had a beginning? Even if it didn't, one can argue that it still had to have a source of being. It still was created, had to have a... I think the fact the universe had a beginning is important theologically, not because it proves a creator, but because it's consistent with our view that the universe has a kind of purpose or point, that it's not just a meaningless one darn thing after another. You know, a story usually has a beginning, a middle, and an end. You know, it's going somewhere. A story is going from something to something. Actually, by the way, that is a very mysterious fact about our universe that is not understood by physics at this present time, that time has an arrow. If you look at the fundamental laws of physics, the fundamental laws of physics do not prefer, they don't really see a difference between this direction in time and that direction, symmetric. So why is it that in our universe, events always seem to flow one way? You know, all of us are getting older. It's not some of us are getting older and some of us are getting younger. No, we're all, irreversible processes always go in one direction. There's an arrow to time. And that is not well understood. It has to do with the second law of thermodynamics, but the ultimate reason why time has an arrow is not understood. But it does have an arrow. The universe does seem to have a beginning, a middle, and as I'll talk about in a moment, an end in some sense. So it's like a story. Okay? If the universe didn't have a beginning, a middle, and an end, it would be sort of pointless. For example, if the universe's history went around in a circle, it just kept repeating itself over and over, it would be kind of pointless, like a hamster wheel. It's not going anywhere. Anyway, but let me now get to the question I alluded to, which is, will the universe have an end? So I'll talk about what Revelation says about that and let me skip that. Will the universe come to an end? Well, at first glance, the scripture seems to give a pretty unambiguous answer. So it says, long ago, this is Psalm 102, long ago you laid the foundation of the earth, and the heavens are the work of your hands. They will perish, but you endure. They will all wear out like a garment. You change them like clothing, and they pass away. In Matthew, it says, heaven and earth will pass, Jesus says, heaven and earth will pass away, but my words will not pass away. 1 Corinthians, the present form of this world is passing away. First letter of John, and the world and its desire are passing away. And 2 Peter, the present heavens and earth have been reserved for fire. The heavens will pass away with a loud noise, and the elements will be dissolved with fire. So they're pretty consistent, right? All the New Testament writers. This world is passing away. Now, what does science have to say? Oh, here's Revelation. Then I saw, so at first glance you say, okay, the world's coming to an end, the end of the story. Let me just see if I have something to visit. Let me go back. Now, what does physics tell us? Well, physics, up until 1998, the standard story was there are two ways that the universe could develop. One way is if the expansion eventually reverses in itself and turns into a collapse, it will end with a big crunch. So there'll be an actual time when there's no more time, no more space, no more matter. The universe will come to a screeching halt, okay, at the big crunch. But it also could be that the universe just keeps expanding forever. The universe wants to collapse, so to speak, because gravity is pulling it together. And the question is only whether the gravity pulls it together so strongly that eventually the expansion's turned into a collapse, like a ball that goes up and then falls back down, or whether the gravity will slow the expansion but never enough to reverse it, like when you throw a ball up with escape velocity and it'll keep going forever, slower and slower, but it'll keep going up. And that other possibility is the universe expands forever. In that case, what will happen is eventually it'll last forever, but eventually all the usable energy in the universe will have been used up. Stars will have burned all their fuel. Stars will stop shining at some point. There's just no more fuel left. All usable energy, forms of energy, will be gone, and the universe will approach absolute zero, get exponentially close to absolute zero. It'll be darker and darker, emptier and emptier. Actually, eventually, almost all the matter will disappear. It'll just be cold, dark, empty, and lifeless. For a reason, it sounds paradoxical, but that was historically called the heat death of the universe. Okay, you say, why is it called heat death? It's getting colder and colder. Because they didn't, that term arose, they didn't know about the universe expanding. They just said there'll be a certain point at which all usable energy is exhausted, and it will go from the form of usable energy into the form of heat. And so at that point, that's called the heat death, and nothing interesting can happen after that. But we now know that all the usable energy will go into the form of heat, but because of the expansion of the universe, that heat gets dispersed over larger and larger volumes, so the universe actually gets colder and colder. But either way, at a certain point, there's not going to be life in this universe, either because it'll end or because it'll be cold, dark, and empty. But even before any of that happens, the sun is going to become a red giant, they tell us, in about 5 billion years, and just incinerate everything on the surface of the Earth. So whatever what cosmology tells us, the Earth is going to get incinerated in 5 billion years. So there won't be any life on Earth, or for that matter, on any other planet in the universe after a certain point. So it looks like we're in agreement. Scripture says it's passing away. Science says it's passing away one way or the other. It's a little more complicated because we also read in Scripture that there will be a new heaven and a new earth. Okay? That's referred to in Isaiah. It's also referred to in the book of Revelation. I saw a new heaven and a new earth, for the first heaven and the first earth had passed away. And so there is this idea that something will replace this. Now, it's ambiguous in Scripture whether the new heaven and the new earth are simply a new thing, that this world is just gone and replaced by something else, like you might get rid of one car and buy another car, or whether the new heaven and new earth are a transformed and renewed or renovated version of this universe. And that's ambiguous, though Christian tradition favors the idea that the new heaven and new earth are related somehow to this heaven and earth, and that they are a transformed version of this heaven and earth, heavens and earth. But that raises various problems that I'm not going to go into, because we believe that this next world is going to be one that, as St. Paul says, will be free from the bondage to decay. So, in the next life, we're not going to be dying and growing old. It's a realm where there's not decay and death. And how that would work is very mysterious, okay? I'm not going to go into that. I actually have an article on the Society of Catholic Sciences website that talks about this question. St. Paul talks about this in 1 Corinthians, the question of how can it be that in the next world there'll be no corruption and decay. And so that's a very interesting question. But in any event, we're told that we can't really understand the issue. Well, actually, here's St. Paul reflecting on this. He says, flesh and blood cannot, in this world, we're corruptible, we're perishable. Okay? We die, we're mortal. From a physics point of view, that's because of the second law of thermodynamics. Flesh and blood, he said, so the next world is not like this. And therefore, he's sort of arguing that the next world has to be very, very different from this world. Otherwise, if it's too similar to this world, it will be a realm of perishability and corruption and death and decay. And that's why he says flesh and blood cannot inherit the kingdom of God, nor does the perishable inherit the imperishable. And he says, we will all be changed in a moment, in the twinkling of an eye, at the last trumpet. For the trumpet will sound, the metaphorical trumpet, and the dead will be raised imperishable, and we will be changed. For this perishable body must put on imperishability. And he argues from this that the next world will be radically different from this world. And, but we're also told that we don't know what this other realm will be like. John, first letter of John says, what we shall be has not yet been revealed. And 1 Corinthians says that the next world, the new heavens and the new earth, are unimaginable to us. It says, what no eye has seen, nor ear heard, nor the human heart conceived, what God has prepared for those who love him. So it's a very mysterious thing how this new heaven and new earth are related to this heaven and earth, how they can be places without corruption and death and decay, and what it will be like. Very mysterious, but we're also told that it's something beyond our present imaginings, and so probably all attempts to imagine these things are doomed to failure. And that's where I'll stop, with the end of the universe. Yeah.
So to go back to your discussion of Stephen Hawking and the quotations you
Right.
put up, back in near the end of his life, whatever the last book was,
Right. 2010. It was called, I think, The Grand Design, I think it was called. Yeah.
yeah, that I agree that it's superficial, but repeated. So one thing that I thought I understood from his argument was that he had come to what you might call a more philosophically realist as opposed to nominalist or modelist account of the laws of physics.
Mhm.
So the one quotation that equations that just describe the universe.
Mhm.
But I think, if I recall correctly, the claim he was making was, to use your example of the rules of baseball, that in the rule book for baseball, the rules were so constituted that the game of baseball would have to be played by eternal necessity. Now, there's still a contradiction there, but is that...
No, I mean, that's what he's trying to say, but I think it runs afoul of his earlier argument. When he says in 1988 that the usual approach of science of constructing a mathematical model, I would prefer to say theory. Constructing a mathematical theory cannot answer the question. The usual approach of science back in 1988 is still the approach of science today. In that respect, nothing has changed. There's a set of equations, and those equations accurately describe. There's a big discussion among philosophers whether the laws of physics are merely descriptive or prescriptive. I think they're both. I would say they are like the rules of a game. Now, there's some laws that have to be what they are. The laws of arithmetic, 2 + 2 has to be 4. It's not that somebody decided a long time ago, or at some point, or God decided that 2 + 2 should be 4, not 5. It has to be 4 by logical and mathematical necessity. But the laws of physics are not like that. They're more like the rules of a game. So if you're watching a game of chess and you say, oh, I notice these patterns, bishops always move along diagonals, rooks do this, knights do this, and so on, and there's a set of rules. Why are the pieces following those rules? Because somebody agreed to play by those rules. They could have, in fact, they often do play by other rules. There are various variants of chess that people play for fun from time to time. But the reason chess is played by those rules is somebody chose that those would be the rules of chess. And in the same way, the laws of physics are just a set of rules that prescribe how things should act in the universe. But it's perfectly consistent. If you come up with a mathematical theory, whether it's superstring theory or supergravity theory or any theory of physics you like, a mathematical structure, is perfectly consistent to say that there's no universe at all. That nothing exists. As Leibniz said, why is there something rather than nothing? Well, the possibility, we know it's not true because we're here, but a priori, the idea that there's simply nothing in existence for these equations to describe, I mean, there's just nothing, is perfectly logically and mathematically self-consistent. the equations no more, as I said, the equations no more have a power to make there be a real universe than the laws of chess or the rules of chess have the power to make there be an actual chess game being contested between people. They're just not. And there's nothing about the laws of quantum gravity that are any different in that respect. He's talking in his later book, he says quantum gravity will explain it. No, it won't. It won't explain why. It might explain why there's a beginning. It could be when you solve the equations of some theory, that any universe described by those equations must have a finite age. That's possible. It doesn't mean there has to be a universe of that sort. But if there were, it would have to have a beginning. But there doesn't have to be one. Okay. Yeah, so if he had somehow deluded himself later into thinking that somehow equations could magically make there be real universes, then he's just deluding himself. I mean, and it's not just me saying that, it's the earlier, I think, more clear-thinking Hawking who said that. Yeah.
What do you think about the possibility that we are living in a simulation? And how would you
I don't know what that gets you. So, like, I mean, does that explain anything? I mean, in physics, people come up with theories to explain things that are otherwise puzzling, or to explain some phenomenon. I don't know what saying this world is a simulation what that would question that would answer, or a problem that would resolve, or what does that get you, really? I mean, I'm prepared to think about it, but I don't know that that solves anything or answers anything. Also, I think the universe, any universe, that means that there's a other universe in which there are these people with very fancy computers, and we're just a simulation. Well, that universe has to be much fancier than this universe, I would think. We certainly in this universe could not simulate something like this universe. So it would have to be a much fancier universe. I think that just, and then are they a simulation too? And then you get an infinite regress of simulations. I don't know that that makes our picture of reality any simpler. Yeah, back there.
There's a common belief like the ark, that the ark is 6,000 years old.
Yeah.
Do you care to comment on that, or what is
There's this notion that the world is 6,000 years old, and would I care to comment? My only comment is it ain't so. So, yeah.
Yeah, so I wanted to talk a little bit about the arrow of time.
Yeah.
Because I just want to pick your brains and see what you think. What do you think about the philosophical concept of eternalism? The idea that the past, the present, and the future are all equally real. And we're just moving through time in one direction.
Mm-hmm.
But the past that we left behind doesn't cease to exist. It's still there.
Right.
We just can't travel backwards.
Right. This is a very long thing that philosophers, there's eternalists and presentists, I think. People debating the nature of time, which would be a long discussion, which I have my own private views about this. Some people say that physics treats time like space. And there's a certain truth to that, because we talk now, after Einstein's theory of relativity, about living in a four-dimensional space-time with three space-like directions and one time-like direction. So in a sense, time has been integrated with space into one structure called space-time. And some people, philosophers, are unhappy with that because they say it makes time just like space. And therefore, time is somehow unreal, because you could say, well, I exist here and somebody else exists in England at a different place in space, but we're both equally existing. And being at different points in time, can I just say that my grandfather still exists, but just at a different point in time? I mean, if we make time to be just like space, maybe my grandfather actually in some sense exists, but just in a different place in space-time, just as somebody might exist in a certain different place in space. Well, I mean, the trouble, I would just say one thing from a physics point of view. I don't want to get into philosophy, but from a physics point of view, the idea that physics treats time as just like space is actually not quite right. At a certain level, it does, because as I said, if you just talk about the geometry of space-time, space and time are very similar to each other in certain respects. However, when you talk about the laws of physics, there are equations, there are laws that are called the dynamical laws. The way matter behaves is governed by a set of what are called dynamical laws that govern how things change. And they're sometimes called, in classical physics, the equations of motion. They tell you how things move and change. So these dynamical laws do not treat space and time the same. They treat them very, very differently. And so the world, physics does not think that time is an illusion or it's really no different from space. It really treats time as very different from space and is not at all illusory. And that's all I'll say on the subject. So actually, physics doesn't tell us anything about time that goes against it tells us certain things that go against our intuition. So for example, it seems intuitively clear, and did up until 1905 to everybody, that you can talk in an absolutely meaningful sense of two events that are different places being simultaneous. You know, that seems like, yeah, that makes sense. Something happening here, something happening in the next room, I can talk about whether they're simultaneous or not. But relativity tells us that actually that doesn't, strictly speaking, that depends on your frame of reference. It's not an absolutely meaningful statement. However, the things that really matter about cause and effect, all our intuitions about causes and effects and so on, they're preserved by physics. Physics does not overthrow anything that's really important in our way of looking at the world, way of looking at time. So according even to special relativity, general relativity, if an event A happens and it causes event B, then there's an absolute sense in which A comes earlier than B in time. Things always produce effects that are later in time and are in fact affected by things that are earlier in time. So that's our experience. Causes precede effects in time, and relativity does not change that. So I would say, don't worry that physics is telling us things about time that are just overthrowing these fundamental convictions we have about cause and effect and so on. It isn't really. Physics has to reproduce the things that we observe and experience, or it's no good. Okay? If physics isn't describing the world accurately, then it's no good. It's wrong. And so a lot of our intuitions about time and space and so on physics has to be consistent with them because we know that they're true. And I'm here to tell you that, in fact, there's nothing that physics has told us about time that makes it in any way illusory or anything like that.
Well, that's not exactly what I was asking.
I know, but it's the only question I can answer in a finite time.
I guess sort of the catalyst for this question, and this is, I guess, more of your scientific opinion. So, the way that you see time and space, or the way that physicists as of now see time and space, in theory, would it be logically possible to travel to the past or the future? Like, does that exist?
Okay, now, it has never been rigorously proven. Now, there is time travel in a certain way is possible. We travel to the future. Just stand here and wait for 5 minutes and you have just traveled to the future. The interesting question is, can you go to the future and then come back, as in H.G. Wells' time travel story? Or can you go into the past? Can you go into the past or go into the future and then return?
Like great-great-granddaughter.
Right. Now, it would be a terrible thing if we could, because it would lead to all sorts of paradoxes. You know, the famous grandfather paradox. If I could travel back in time, I could go, I don't know why I'd want to do this, but I could go and I could I better be careful, I'll probably get canceled for saying things like that. I could go back and make it such that my grandparents could never reproduce, and therefore I would not be born. Well, that's obviously a contradiction. If I go back and say, do something to my grandparents, so they never had children, and then you have a self-inconsistency, because then I wouldn't be born, and then I couldn't have gone back and done that. And so that's something that physicists are well aware of, and physicists regard as rather, I wouldn't say sacred, but pretty important what's called the principle of causality. They call it causality, that you shouldn't be able to affect the past or to travel into the past. Now, in special relativity, you can't, because you can easily show that you cannot travel into the past. But with general relativity, where you have space-time getting curved and so on, it seemed to open possibilities for actually make it conceivable that you might be able to travel into the past. One way you might do this is by what's called a Minkowski wormhole. So it's sort of like an off-ramp. Think of a highway. So one thing we know is think of time as like a highway, and you're not allowed to turn around on the highway and start driving backwards, okay? The laws of, you can't go backwards in time. But what if everybody has to drive in this one direction on the highway from past to future? But what if there was an off-ramp that took you and then curved around back and hooked up to the highway somewhere miles behind you? So you're still driving in the right direction on the lane, but the lane loops around back, and you end up going backwards, even though you haven't turned your car around. Well, something like that you might imagine could happen in physics. And in fact, you can construct solutions of Einstein's equations where there's a kind of tube comes out of space-time and curves around back and hooks up again into the past, and you might imagine traveling through that tube and going into the past. The trouble is that those solutions to Einstein's equations require that there be certain kinds of matter in existence which do not seem to exist in our universe. Having such wormholes requires space-time to curve in a particular way. The way space-time curves is governed by matter. Matter is what curves space-time. To curve space-time in that way that would allow you to travel into the past that way, you have to have a very strange kind of matter that has negative energy. It doesn't seem to exist in our universe. And so the general feeling is that this is not possible. It's not actually possible in our universe. And no one has rigorously proven that time travel is absolutely impossible. But every time people have thought they have found a way to do it, they find out that when you look closely, it turns out not to be possible. And this has made physicists have a strong conviction. This has reinforced their belief that it's not possible. But the real reason physicists believe it's not possible is that they think it would be a kind of insane world to have these paradoxes where you can go back and sort of make it kill your grandparents before they reproduce. You run into paradoxes that are intolerable, and so that's really why they don't think it's possible. One more, okay.
So I was just wondering kind of what your analysis of the multiverse theory is, and if that has any implications.
Multiverse, I'll just say this. A multiverse idea is not as most people think of it. First of all, it's something that most physicists do not think about very much. And the reason they don't think about it is for several reasons. By the way, I don't dismiss it. I think it's a very important and interesting idea that one ought to think about and take seriously. And I don't think it's at all crazy or far-fetched. But most physicists do not like to talk about it. One, because it's almost certainly untestable. If we do live in a multiverse, it's probably not possible in practice to show that. So it's an untestable idea. Second, there's not a shred, and this is connected to the first point, there's not a shred of evidence that we live in a multiverse, and there's no theoretical reason to think that we do. It's a pure speculation and probably an untestable one. That being said, what do people mean when they talk about it? They're not generally talking about many universes that have nothing to do with each other. They're generally talking about a multiverse is generally conceived of as a type of universe. It's a single entity. Okay, it's a single universe that has many parts or domains or regions in which things in one domain or region look very, very different from things in some other domain or region. So it's a universe that has a lot of variety to it, but it's still one universe. And in particular, what some people think about, isn't it possible that some of the things that we have always thought were sort of constants of nature, say the mass of an electron, you can look that up in a book, look this up. You can read what is the mass of the electron. And we know the mass of the electron is the same here and in distant galaxies and early in the universe. We can tell that. But people say maybe in parts of the universe that are very far away, so far away we can't see them, maybe the mass of the electron takes different values. Or maybe the strong force of some force, maybe electromagnetism, is a different strength here and in some very far away region. That's what they mean by a multiverse, that the universe has many different parts and certain very basic quantities of physics change from one region to the next. And that is an interesting idea. It could be the case. I don't think it's any threat to our faith. I don't think is anything to fear there, but I also don't think there's no real reason to believe that that's the way things are, and or that we'll ever know one way or the other. So it's pure speculation. Okay.